everybody. In this video, we're going to look at lesson 1-3, topic 1, example 1. In example 1, we're going to look at a conceptual understanding of what a piecewise function is. So we're going to model with a piecewise function. So this example starts out with Alani, and Alani has a summer job as a lifeguard. She makes the standard $8 an hour for 40-hour weeks, but if she works more than 40 hours, she makes what's called time and a half, or she'll make her $8 plus another $4 to make it $12. So it's for so once she hits 40 hours, it's for every hour after. So if she's working 41 hours, she gets $12 an hour there. How could you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she worked? So I'm going to jump over here to Smart Notebook. I'm going to get my handy dandy pen. And what I've created here in my Smart Notebook is a T-chart and a graph. So in my T-chart, let me push my computer back a little bit just so I have some room to write. In my T-chart, I'm going to make hours worked and over here I'm going to put her pay. And this is going to be my X values and these are going to be my Y values. So I'm just going to jump straight to, she'll probably work 20 hours at least a week. Maybe a little bit less. It all depends if she's in school, but I'm just going to start it at 20. And with that, her pay would be $160 or 20 times 8, which is 160. Then I'm going to do 25, which is going to be 200. 30. 30 is going to be 240. 35, which is 280. 40, which is 320. Oh. 45. Oh, and then here at 45 hours, we are no longer doing this by $8 an hour. For the extra 5 hours, so the extra, I think those are the same color. For the extra 5 hours, she is getting paid 12. So in this case, we are looking at the original 320 that she received plus 5 hours times 12. So this 320 is for the initial 40 hours. And then the next group, so this would be some value X times 12 after that 320. So that's going to be 320 times 5 times 12, which will give us 380. At 50 hours, we are looking at 440. And I'm just going to go a little bit further. I'm going to go to 55. So at least we have 3 data points in our new chart. And this is going to be 500, or in our new data set. Okay, looking at my graph, I'm actually going to move this over here. Let me step more over on that side. Looking at my graph, my x-axis is going to be hours worked. Hours worked. And my y is going to be her pay, her money. I think this one, I'm going to go by tens. Go to 55, so I'm going to go to 60 here. Let's see, we're looking at 500 as the max. So 1, 2, 3, 4, 5, 51, 52, 53, 54. Nope, let's go 1, 2, 3, 4, 5. So 100, 200, 300, 400, 500. Okay, when we're looking at her working hours, when she worked 20 hours, she got $160. So she was roughly right here. When she worked 25 hours, she was roughly 200. 30 hours was 240. 35 hours is 280. And 40 hours is 320. And we know after 40 hours, we're going to get a new, because this one right here was at 8 times X, or the number of hours she worked. Here we know that we're adding the 320 to it. So here we know right here, at this point right here, we're getting a different function or a new function. So I'm going to start this function out and end it at 40 hours. So bam. Now right here, when she gets paid time and a half, I'm going to do this in the color red. So at 45 hours, she's making $380. At 50 hours, she's making $440. And at 55, she's making $500. So there's a slight change in the slope of this new graph. Just a very slight change, but it does do this kind of like come up, and then it goes kind of like this. This is more exaggerated than what you see here, but this is the idea of what it actually does. All right, so when we look at this, let's go back to our solution here. So here's the table. You could actually see the kind of bend here a little bit better than my drawing. So let's scroll this down. Look at step 2. So notice that the plot contains 2 linear sections or segments with a slope that changes slightly at x equals 40. A function that has different rules for different parts of the domain is called a piecewise function. So I would pause the video at this moment and let me scroll this down. And I would write down a function that has different rules for different parts of its domain. And again, domain is your x-axis, is called a piecewise function. So pause this, write this down, and come back to this video when you are done writing this definition down in your notebook. All right, step 3. We want to write the function. So write an equation for the piece of the graph. So when we're looking at the graph here, we know that this one right here, from, I'm guessing it's less than, oh, let me get back to my, I'm going to put step 3 here. So we have conditions where it's less than or equal to 40. And then we have a condition where it's greater than 40. Right, and in my condition where it's less than or equal to 40, we need to find the function for this graph right here. Now, if she works 0 hours, then she gets 0 pay. My y-intercept is 0. And in a linear function, y equals mx plus b, this b component right here, this is your y-intercept. So our y-intercept is 0, so we know we are adding 0. Our slope in this case is going to be 8. Because if I did rise over run, this run is 20, this rise is, go back up here, 160. And so 160 divided by 20 would be 8. So we're looking at an 8x here. But once we hit 40, once we get greater than 40, we change. We need to account for this 320 here. We need to account for this jumping at 320. So how would we be able to do this? How would we be able to find that y-intercept so we could do the plus b? I mean, do we do the 320 plus 5x times 12? Is that really a great one? So I'll give you a second to pause and think about how we actually find our y-intercept. So here's a clue. We could actually find our slope. From our slope, we have xy positions. So with the xy positions, we can find where it crosses the y-axis. So when x is greater than 40, Alani's pay is P of x equals 8 times 40 plus 12 times x minus 40. So why do you think they did the x minus 40? Well, what they're trying to do is they're trying to do that horizontal shift. They're shifting this back so that we have an original thing here. So we've actually shifted this right 40. And if I were to look at the original red graph, boop, 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 this would go down like this. And we would have some negative value here. And to compensate for this shift over, they basically said minus 40. All right, so our slope in this case is going to be 12 because she's making $12 an hour minus 160. If I were to look at this, this roughly goes to 160. Oh, I just lost this original one. So again, it's going to be 8 times 40, which gives us this 320. Plus 5 or 12 times x minus 40, because again, we've shifted off to the right. So our two equations are going to be 8 times x. Let's see, let me move me out of the way a little bit here. So our two equations are going to be 8x when it's 0 to 40. And again, this is our domain, so I didn't put the 0 here, but we should include it because she cannot work negative hours. Oh, you lost me. There we go. And then the second one is that second equation, 12x minus 60, or 160, for when x is greater than 40. We have two different functions now, but when x becomes 40, that's when one function ends and the other one begins. So the notation is used for piecewise defined functions to indicate the different functions at different parts of the domain. So at this part of the domain, we go from this black line and this red line takes over. That's what this all, this is 12. And that's what this means. So the y equals the curly brackets, 8x, for the values 0 to 40, and then after 40, she's making more money. So then we have 12x minus 160 for greater than 40. All right, so in this next try it, let's see what you will be doing. So Alani has a summer job as a lifeguard. She makes $8 an hour for 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $12 an hour for each hour over 40. How much will Alani earn if she works 37 and 43 hours? So all you have to do is, again, look at your table, look at your functions, plug those into your functions, and get your answers. So this is the end of example 1. Next video, we'll cover example 2.